Alrighty, we are going to complete the square today. Completing the square is awesome. It is a way to solve a quadratic instead of factoring or using the quadratic formula. It allows us to take square roots, but we need a little bit of prior knowledge. You can see here, I'm going to be doing a quick example where I do turn a quadratic into a perfect square so I can take the square root of it. As previously mentioned, we're going to need to be able to know what a perfect square binomial is. A trinomial, I should say. A perfect square trinomial is where both factors are the same. So here are some perfect square trinomials. When I factor each of these, the factors are the same, so we can write them as a perfect square. There's more information on this link over here. Alrighty, so we're going to do an example here. We have x squared minus 10x plus 7. So the first thing is we need to figure out what we want c, the last number, to be by taking half of 10 squared, which is 25, and we're going to add 18 to make that happen. At this point, we can factor, finally, a perfect square. And when we have a perfect square, we can take the square root of it on each side, and we'll get a weird radical here. I like to simplify at the end. I realized my pen didn't work, and here we go. I'm adding 5, and I'm going to simplify. You might want to review how to simplify square roots. Reassure yourself you did a good job. Oh, that's pretty weird. Oh, I don't know what happened there. Here's an example where there's a leading coefficient, meaning there's a number up front, so we can divide it all the way out, and then this problem's almost the same. We find out what we need to add on the end. We subtract it, 1 from this time, to make it a perfect square. Again, we're taking half the middle number squared. We run into a little bit of an issue here, though. We have our perfect square, but it's equal to a negative. We might think to ourselves, can we take a square root of a negative? Yeah, we can. So we're going to go ahead and take the square root and call that -1. It's just I, our imaginary number. And we can still subtract 2. We can't combine it with I, so we'll say x equals -2 plus or minus I. A little note on that, if you ever get weird fractions, you might want to choose a different method. Check out my sweet moves. Alright, our last thing we're going to do is we're going to convert from standard to vertex form. So it's going to be the same idea. We're going to complete the square. We're going to figure out what do we need to add to each side. In this case, it's 18, but we can't combine that 18 with the y, so we're just going to let it chill there for a moment. Once we've done that, we can factor one side to be a perfect square. But instead of taking the square root, we're just going to move that 18 back over by subtracting it, and that leaves us in vertex form now. I know that 6 kind of looks like a B there, but it's a 6. So there you have it, complete the square. You need to know your perfect square binomials and how to simplify radicals, along with use imaginary numbers. So try the examples on your note sheet, and we will be talking about them next class.